Good afternoon, everyone. I'm Uma Maheshwari, Assistant Professor, Department of Electronics and Communication Engineering. In this particular video, I'm going to explain about Qpsk. It is one of the type of PSK. PSK is nothing but phase shift keying, whereas Qpsk is nothing but a quaternary phase shift keying. Whereas in phase shift keying, the phase of the carrier is varied to represent two or more different signal elements. Peak amplitude, that is both peak amplitude and the frequency remains constant. In BPSK, we have only two signal elements, one with the phase of 0 degree and other with the phase of 180 degree. Where bandwidth of binary PSK. PSK is less susceptible to noise than ASK, where PSK is superior to FSK because we do not need two carrier signals. Where here this is the implementation of the BPSK, where if we give the signal as 1, it will be in the positive half cycle. If it is 0, it will go in the negative half cycle. So then the carrier signal, and then we'll get a modulated signal where if it is 1, the signal goes as like it is. If it is 0, it will be tilted slightly from 1 to 0. That is called as a binary phase shift keying. Whereas a phase shift keying is a method of digital communication in which the phase of transmitted signal is varied to convey information. There are several methods that can be used to accomplish PSK. A digital modulation scheme that converts data by changing the phase of the carrier wave. You can either determine the absolute phase relative to the unmodulated carrier or reference signal or the carrier in phase. The number of different phases used determines the amount of data that can be transmitted in each cycle. In binary phase shift keying implementation, the amplitude, that is in y-axis will be having amplitude, in x-axis will be having a time period, that is baud rate. That is what is displayed here. Then QPSK. In QPSK, that is mainly quadrature phase shift keying. It mainly increases the bit rate. We can code for more bits onto a one single element. Whereas in QPSK, we parallelize the bit stream so that every two incoming bits are split up and PSK carrier frequency. One carrier frequency is phase shifted 90 degree from the other in quadrature. The two PSK signals are then added to produce one of the signal elements. QPSK and its implementation, where we'll be having a 2 by 1 converter, then oscillator. From the oscillator, we'll have multiplier and it is up to the summation. Like that it will be there. Then three constellation diagrams are there. Yes, first one is ASK, next one is BPSK, final will be called it as a QPSK. The main advantages of this binary phase shift keying is it allows data to be carried along a radio communication signal, which can be much more efficiently used than with the frequency shift keying. Whereas in quadrature phase shift keying, this is the another form of data transport where four phase states are used all within 90 degrees of one another. The main disadvantages of this is that it is a non-coherent reference signal. It produces more incurrent demodulations because the error can integrate with time since the reference signal for demodulation is not fixed. Whereas in this quadrature phase shift keying will be having a we'll be having the constellation diagram as seen in the first three slides, and also we have seen about the QPSK modulator and the demodulator, where here the bandwidth efficiency is being calculated and the transmission rate, then baud rate, bit rate, everything will be calculated um, in this quadrature phase shift keying. This quadrature phase shift keying is mainly used in order to detect the reference signal. That's why we'll be see the disadvantages of this is it is non-coherent reference signal and it can produce more incorrect demodulations because the error can integrate with time since the Reference signal for demodulation is not fixed. The main applications of this is optical communication, local oscillator, delay and demodulator, non-linear effects of WDM transmission, and finally multi-channel WDM. Thank you.